Hello everyone and welcome to the Wevolver Digest. Today we're going through space and through 5 topics that you might have missed in the wake of all these Starship crashes. We're looking at NASA's new SCALPSS mission, the Perseverance landing, some university projects, and the status of the Ariane VI. My name is Ole, I'm a mechanical engineer at ETH Zurich. Today I'm going to present these 5 space topics to you. Let's jump right into it with SCALPSS. Behind this long acronym is the Stereo Camera for Lunar Plume Surface Studies. It will give us a clearer understanding of the behavior of dust during the landing approach. It is scheduled for the October of this year to fly with the Intuitive Machines Nova-C lander under the Commercial Lunar Payloads Services program, encouraging more private companies to the moon. It will investigate how the landing is affecting dust generation and will land in the deep and narrow Valles Schroeterي. It is equipped with 4 cameras that will record stereographic 3D images of the landing site during the approach and after touchdown. Lunar dust is extremely abrasive and even toxic to our bodies, causing allergic reaction and even lung cancer. Eugene Cernan said it is probably one of our greatest inhibitors to a nominal operation on the moon. In order to have a successful lunar outpost, NASA is now announcing 7 university teams that will receive $1 million to tackle this problem. SCALPSS is entering thermal and vibrational testing now to be ready for its maiden flight in the autumn of this year. It is the second planned lander to make a touchdown on our moon. The next one coming up is NASA's Peregrine Lander after the last successful Chang'e by the Chinese. 250 students from Michigan University were involved in building the MiTEE CubeSat. It's actually a tiny CubeSat that employs a space tether. And before you go all skyhook or space elevator on me, calm your horses, calm your horses. Let's hear from the experts how an electrodynamic tether actually works.
It's not using the rocket equation. We're not throwing something out the back to move forward, but instead we're pushing and pulling against the Earth's magnetic field. That tether pulls out straight and it's moving across the Earth's magnetic field. You have to think of it like sailing. We can go where the Earth's magnetic field and the ionosphere lets us go. It allows us to collect electrons at one end and emit electrons back out into the ionosphere and let the ionosphere behave like a big electrical ground.
You could have satellites as small as a cell phone that could stay up there for ages, essentially.
There's a lot of components, a lot of things going in. No one has really succeeded in doing this before.
It's been like the cornerstone of my time here at Michigan. I have made my mark on something that's actually going to space. That's just wild.
Looking up in the sky with a telescope, you see a glimmer of lights, and you can say, that's my satellite up there.
Tomorrow Perseverance is landing and you should watch it live. It's an amazing feat of engineering and will bring us closer to finding life on Mars. Let's hear from the experts why that is.
Mars is the closest place that we can reach with robotic exploration that we think had a really good chance of having ancient life.
The Perseverance rover will land at a location called Jezero Crater. Jezero Crater is a very interesting place. It's a crater that once held a lake. It had an inflow channel and it had an outflow channel. That means it was filled, the crater was filled with water.
In Jezero, we have probably one of the most beautifully preserved delta deposits on Mars in that crater.
This is a wonderful place to live for microorganisms, and it is also a wonderful place for those microorganisms to be preserved so that we can find them now so many billions of years later.
There is no other place on Mars that has the unique combination of a lake setting, a beautifully preserved delta, and the diverse mineralogy that we have in Jezero Crater. So it's truly a special landing site.
To get there, Perseverance will go through a 7-minute descent, which is the first ever completely autonomous landing on Mars. It will use supersonic parachutes and a propulsive descent stage. This design already proved reliable for the Curiosity rover back in 2012. The descent stage will upsile the 1-ton SUV-sized rover onto the Martian surface. It will then detach and crash into the surrounding terrain. Perseverance itself is packed with scientific equipment. There are Sherlock and Pixel, 2 spectrometers that will aid the search for microbes on Mars. MOXIE, a device the size of a car battery that will demonstrate the production of oxygen from the Martian atmosphere, and for the first time we bring microphones. And of course, Ingenuity, the first Martian helicopter. It is a proof of concept that investigates whether aerial propeller-based exploration is feasible on Mars. During 30 days, it will do up to 5 test flights collecting data for the next iteration of Martian drones. If everything goes to plan, it will map out the surrounding up to 50 meters away from Perseverance. It has been tested on Earth in Mars-like atmospheres and is built to be as light as possible. The propellers are revolving at more than 2,000 rotations per minute. Perseverance is also part of the sample return strategy. It will collaborate with the European Space Agency to collect these samples by 2030 and send them back to Earth. There they will be investigated by scientists here in our laboratory, which enables a way more detailed analysis. MIT loves ion propulsion. You might have heard of the ion plane that recently flew 60 meters, powered only by ions. Now they've done it again. They created a very low-cost ion propulsion for satellites. Before we go into details, let's see how it actually works. A gas, or in our case a fluid, is ionized by electrons and then accelerated with an electric field. They shoot out the back, and if you repeat this often enough you get a thrust. It's not a lot, but it's enough and super efficient. At MIT they created 2 different designs, one with stainless steel and one with a polymer. You can see on the right that they also coated it with some sort of needle-like forest. This is generated by another chemical in order to create a better wetting of this ionized fluid. Then we can see here a little bit more detailed view of what the design looks like. In the bottom you have the fluid container, and then this fluid comes out through these holes, goes through the emitters, and on the emitters you have the current that actually shoots it away. The stainless steel was created by binder jetting. Binder jetting allows a really fine geometry, even finer than selective laser melting, because there is no heat impact. You cure some sort of glue or a binder with a UV or a heat lamp, and then you add another compressed metal powder onto it. This allows, as I said, a super detailed structure. The polymer one was created during watt polymerization or stereolithography, as you might know from the Form 1 or similar 3D printers. With advances in 3D printing hardware, these devices could reach emitter densities comparable to those realized in semiconductor cleanrooms. This is amazing. It will help democratize nanosatellite space hardware. The Ariane 6 completed its upper test stage. It just traveled from Bremen to Lampolshausen for the final testing. The Ariane 6 is going to replace the old Ariane 5, go figure, one of the most reliable rockets built by all European countries. There will be 2 configurations, one with 2 and one with 4 solid boosters. Number 6 is going to cut the old price in half and double yearly launches by relying heavily on mass production. The Ariane 6 upper stage is almost 12 meters high and has a diameter of 5.5 meters. It is replacing the old metal upper stage with a new black one. This one is completely made from carbon fiber and modern materials. Without it, the rocket could not reach space. This is because its newly developed cryogenic Vinci engine, with its propellant made of liquid oxygen and liquid hydrogen, provides the necessary thrust to release the onboard payload at a precise location in orbit. The burn time lasts more than 14 minutes, and Vinci can even be fired up to 4 times. This allows multiple payloads to be placed into different orbits. In addition, the control electronics that set and maintain Ariane 6's course through space are housed in the upper stage. The 10-year development plan for Ariane 6 was signed just shortly before SpaceX really proved that they could do it. However, ESA has confirmed that they did not bet on SpaceX failing. The European Space Agency will not bet on reusable rockets. They have stated again and again that they think refurbishment blocks hangars and thus limits production capabilities, driving the price up. Because we can never really know what the future holds, Wevolver keeps you at the cutting edge with daily updates in science and technology. If you like this video, why don't you subscribe for more content like this? See you next time. Stay curious.